In database design, let us see some normalization examples. And before we go ahead, let us see the definitions first of the dependencies. Multi-valued attributes, let us see the example also. Multi-valued attributes or repeating groups. You see in this example, the first row and second row, they are same. So they are repeating. So what does we mean when we say multi-valued attributes or repeating groups? That non-key attributes or group of non-key attributes, those attributes or those values, these three are the non-key attributes, because the underlying student ID is the primary key. So all these three combined, we can say that these are non-key attributes. So non-key attributes or group of non-key attributes, the values of which are not uniquely identified. They are not uniquely identified by directly or indirectly, or not functionally dependent on the value of the primary key or its part. That means if I say 101 student ID, which name I should get? Lenin. But for 101 we have Lenin also, and for these two we have different MSI 415. So 101 is not able to identify Lenin clearly or either units clearly. So these are repeating groups. So what we are talking about multi-valued attributes, they are repeating groups. Then partial dependency. What does it mean? Partial dependency means, in this particular example, customer ID and order ID, because they are underlined, they are our primary key. So when a non-key attribute is what in this? This is name. Name is non-key attribute. When a non-key attribute is determined by a part but not the whole of a composite primary key, means customer ID by itself cannot determine name, because 101 customer ID also has AT&T and 10 and order ID as different, and 101 has AT&T as the name but the order ID is different. But if I combine this customer ID and order ID, means if I say that which customer ID with 101 number and order ID 1234, what is the name of that company, then AT&T will come. Okay, or if I say that 101 AT&T, this we cannot combine. This only these two combination can find out this name. Combination of this is partial dependency. So this is partial dependency. Name is partially dependent on customer ID, because customer ID cannot uniquely identify this name. Then we have transitive dependency, third type of dependency. So what is happening here is, when a non-key attribute determines another non-key attribute, means employee ID in this particular example, employee ID, and employee ID is the only primary key. Now employee ID is able to identify F name, first name, Mary, because we are not having any repeating groups. So employee ID can easily identify F name, L name and department ID. But what about this department name? Department ID is not a primary key, but still it is able to identify the department name, because only by department ID, department name can be found out. This is transitive dependency, means employee ID can find out the DEPT ID, and DEPT ID in turn can find out can uniquely identify the department name. So this is transitive dependency, right? So let us review these normal forms. First is unnormalized. A database is supposed to be unnormalized when there are multi-valued attributes, as we have just seen, or repeating groups. If you have tuples, means the rows, if they are identical, we say they are repeating groups. So now the database cannot be in a normal, they are unnormalized, they have no normal form. Now if we come to 1NF, if you remove these repeating rows or tuples, we say that no multi-valued attributes or repeating groups are there. We say, okay, this particular case, we have found out that the database is in 1NF. We have normalized it to 1NF. And with this, if we add one more feature, means we have no partial dependencies now. Apart from having no repeating groups, we have no partial dependencies now. So we say that okay, our database was in 1NF, now it has the quality of 2NF also. It is in second normal form. And we again add one more feature, one more peculiarity, means 1NF, 2NF we have done already. Now we say that we have no transitive dependency also. So now if the database is having no repeating attributes, there is no partial dependencies and no transitive dependencies, our database is in third normal form. Now let us come to an example. Can you determine in which normal form this is? There is one primary key, ISBN, and these are the non-key attributes. ISBN can identify a title, ISBN can identify publisher, ISBN can identify the address. So all attributes are directly or indirectly determined by the primary key. Therefore, the relation is at least in 1NF, and if it is in 1NF, we'll go for 2NF. Let us see that also. The relation is at least in 1NF, and there is no composite primary key also. There is only one primary key, that is ISBN, and there is no other key which can be combined with ISBN to form a composite key. So since there is no composite primary key, therefore there can't be partial dependencies. There will be no partial dependencies, as we have seen in our discussion earlier. Therefore, the relation is at least in 2NF. This relation is also in 2NF. Now let us come down to the third version, means 3NF. Publisher is a non-key attribute. This is a non-key attribute. But the publisher determines the address. Publisher has address. Every publisher has a unique address, right? So publisher can identify the address. Therefore, there is a transitive dependency, means ISBN is able to identify publisher, publisher is able to identify address, which means that the relation is not in 3NF. Transitive means if there is transitive dependency, the relationship cannot be in 3NF. Okay, we know that the relation is at least 2NF and it is not in 3NF. Therefore, we conclude that the relationship is in 2NF and not in 3NF. So how we are going to write it? You have to write it, if you have some exam, then you can write it that no multi-valued attributes, therefore at least 1NF. Okay, you have clarified this already. No partial dependency, therefore at least 2NF, and there is a transitive dependency from publisher to address. You have to write this. Therefore, this is not in 3NF. So conclusion, the relationship is in 2NF. Now let us take one more example. Can you determine in which normal form this relationship is? There are two primary keys, order number and product ID. So this is the functional dependency, means description is functionally dependent on product ID, means product ID can uniquely identify the description. Okay, product ID can uniquely identify the description. So all attributes are directly or indirectly determined by the primary key, means these two are primary keys. So description can be identified by product ID, as it is already given, functional dependency is there. So the relationship is at least in 1NF. But now the relationship is in 1NF, we are happy with this. There is a composite primary key, because composite primary key means when there are number of primary keys, when they are combined, they are said to be composite primary key. Now composite primary key means order number and product ID. It exists. Therefore, there can be partial dependencies, and this is what we don't want in our 2NF. So product ID, which is a part of this primary key, determines description. Hence, there is a partial dependency. So order number can combined way also they can find out this description. So this relationship cannot be in the 2NF. It is not in 2NF. So no sense for checking the transitive dependencies. So this is the description. We know that the relationship is at least in 1NF, but not in 2NF because of the partial dependency. Therefore, we conclude that this relationship is only in 1NF. Okay, one more example. If you want to write, you can write in this way. You have to specify that since this is there, this is in 1NF, and since this can cause a partial dependency, the relationship is in 1NF. This is what for people who are giving exams, for them this will be helpful. Now, how can you identify the normal form of this particular relationship? There is one primary key, part ID, description, price, comp ID, and number. So description can be identified by part ID, as this first condition says, and price can be identified by part ID. This is also given, and this comp ID. Okay, part ID and comp ID, they are together combined to identify this number. Okay, I hope you understood this. There are two keys which are combined, because no a number is functionally dependent on combined part ID and comp ID. So comp ID and number are not determined by the primary key. Comp ID and number are not determined by the primary key. It is not given. See, only description and price can be identified by primary key. What about this comp ID and number? Who is going to identify them? Therefore, the relationship is not even in 1F. So no point in going for partial or transitive dependency. So justification you can write, there are multi-valued attributes, therefore not 1NF. The relationship is not normalized. How can we bring a relation to 1NF? This is a relationship. We have already seen that there are multi-valued. These are repeating groups. So how can we find out? Because student ID can uniquely identify name, course ID can uniquely identify the units. What we are going to do? First, make a determinant of the repeating group, right? Or the multi-valued attribute. These are the multi-valued attribute. Multi-valued attribute means same values. The rows are having same values. So make a determinant of the repeating group as a part of the primary key. As part of the primary key. Like this, course ID, you make it a primary key. And this is composite primary key, student ID and course ID. So remove the entire repeating group from the relationship and create another relationship which could contain all the attributes of the repeating group plus the primary key from the first relationship. These are two primary keys which we have just found out. So in this relationship, the primary key from the original relation and the determinant of the repeating group will comprise a primary key. So how we are going to do it? We are going to do it that student ID and name will have one table, and course and unit will be the other table, but it has to have a student ID also. This primary key should be there. This is how we break or we create two tables from a single table, making the relationship in 1NF. How to make this relationship in a 2NF? Composite primary key is there. So what our goal is in this 2NF, we don't want to have any partial dependency. So we have this composite primary key. These are the two keys. And this is the partial dependency. These are the partial dependency, because student ID can in this whole table, student ID can identify name, but if you combine student ID and this course ID, it can also to some extent identify the other columns. Right? So remove attributes that are dependent from the part but not the whole of the primary key from the original relationship. And for each partial dependency, these are partial dependency, create a new relation with the corresponding part of the primary key from the original as the primary. So what you are going to do? This already I have shown. So you make the student ID and course ID, this student ID and course ID, and then student ID and name, and then course ID and name. So student ID, course ID is one, because student ID can uniquely identify course ID. Then student ID can uniquely identify name. This is also good. This is also given. But what about this units? Only course ID can identify. So you make one more table that course ID is units. Now these all are unique, and they are also having no partial dependencies. And how to bring the relationship to 3NF? This is also important. So what we want to achieve, we want to see that there shouldn't be any transitive dependency. This is our relationship. This we have already seen in one of the example. Now the transitive dependency is employee ID can uniquely identify F name and label department ID, but a department ID by itself, because this is non-creative key attribute, but it can. This is the only key by which the department name can be identified. See, this is a transitive dependency. So what we are going to do? We remove the attributes which are dependent on a non-key attribute we remove those attributes which are dependent on this. This is the non-key attribute. Non-key attribute from the original relationship, and for each transitive dependency, we create a new relation with the non-key attribute which is a determinant in the transitive dependency as a primary key. Okay, let us see how to make it. And the dependent, and this is dependent non-key attribute as a dependent. If you are confused, let us show it by the diagram. This is employee ID. This already you know. This is a transitive relationship. So employee ID, F name, L name, department ID. There is no problem because the employee ID is more than enough to identify first name, last name, and department ID. But what about this? Make the other table in which department ID can be the primary key, and it can uniquely determine the department name. So employee ID can find out department ID, and department ID can find out the department name. So this was our database design and 1NF 2 3NF. Hope you got the idea. Thank you so much. Take care of yourself.